Okay, for this unit we're going to be discussing a new topic called conic sections. At this point you've probably spent a little time researching this and have a pretty good idea of what conic sections is all about, but I'm going to go ahead and go through a quick introduction and touch on a few points that need to be specified, that need to be paid attention to real closely. So here we start basically with 4 conic sections that we're going to be able to create. We have parabolas, circles, ellipses, and hyperbolas. Now depending on where we fall in the end of the year, we may or may not be able to get to all 4 of them specifically, but we'll look at them over the big picture a little bit here. Now, a conic section in general is created as a result of a plane intersecting with a double napped cone, or just one of the 2 cones that are stacked on top of each other. And if you want to think of it kind of like a slicing action, that plane is cutting across the cone at a certain angle, and thus creating the certain cross-section or the shape of the cross-section that creates the conic section. Now, what you're looking at is a 3-dimensional view of a conic section, and you can kind of see by the dotted lines the shape that is being created. Now, if we were to later on graph conic sections on a coordinate plane, we would have the 2-dimensional version of that. Now, each one of these conic sections has a specific equation or graph that goes with them. Now, conic sections in general have a general conic form of an equation, and we'll touch on that a little bit more in each of the individual sections. Once we take that general conic equation and we specify it to the type of conic section that we're dealing with, then it narrows down to a specific standard form of the individual conic sections. Now, these conic sections all have a different look to them based off of their shape, and we'll talk about the specifics of each of the parts of the conic sections within the relevant sections. But here I just want to point out a couple things. In these standard equations we have an h and a k, very similar to what we've been dealing with all year long. Now the h and the k is a vertex in the parabola. For the other ones, it is always representing the center of the conic section. So it may be a center point in the case of a circle, or it could just be the middle of a hyperbola or an ellipse. For parabola, it's always going to be the highest or the lowest point, or the farthest point to the left or the right, depending on whether we're dealing with horizontal or vertical. Now, we'll also talk about the difference between horizontal and vertical axis conic sections, more specifically with each particular conic section. But the one thing I do want to point out more specifically is how to understand the h and the k. If you recall, the h and the k creates a shifting action, makes it slide left to right and up and down, thus moving the center or moving the vertex of the particular conic section. Now, one thing we need to understand, if the h or k is not in the equation, then the vertex or the center of the conic section is understood to be 0, 0. So that's a very important concept. So let's just take a look at the circle, for instance. If I had x squared plus y squared equals 9, well, that would be a circle with a center point of 0, 0 and a radius of 3. And so you can see that we're missing the h and the k in the equation, so that automatically tells me that the center point must be at 0, 0. So this is one of the main things that you need to understand about standard form equations and understanding how h and k is involved in each of the individual conic sections. So that's a good start. Just discussing the general overview of conic sections. Now as we go into each section, we will be specifically discussing each of these individual parts and how it all works with that particular conic section.